So I was reading around, and it tends to be the case that sometimes people are asked to sort of quickly implement, a linked list from scratch. And that's also a good exercise to sort of prepare for questions of that nature. So for my linked list implementation, we're going to have a class, and it's going to be called linked list implementation. And I don't necessarily have to add an access modifier here, since this class is within the same page, as it were, of my main method. However, if this were a different class, in a different file rather, then I would likely have to add that access modifier in order to access this class. However, this is my linked list class. It's sort of resting within the same file as my main method and my solution class up here. However, in this linked list, we know that a linked list structurally consists of nodes, and each of these nodes sort of build the structure of the linked list. It's sort of the meat of the data structure. And each node contains a value, and then it also contains a reference to the next node in line. So within this linked list, I'm not going to start listing out the attributes of the linked list and then the methods of the linked list. I first want to have an embedded class, which is going to be called the node. So since the node is an implementation detail, I'm going to have it contained within this class. And it would also make sense to actually make this private. And that's because when you're interacting with a linked list, you're not necessarily interacting with the node. You are technically and directly interacting with the node, but you aren't necessarily directly changing node values yourself. You're interacting with the linked list, and through the linked list, you interact with the node. So the instance variables for each node, we know that it has a value, and of course we're using a generic type. But in order to actually use a generic type, we have to use angle brackets within which we have the variable t, which would trigger the program to understand that we're using generic types. Now, I could name that variable t anything; it just represents some type. But I choose to use t because that is in fact the convention. So t value, right? I mean, each node has a value, but then it also has a next pointer. So each node as a container contains a value, but then it also has a pointer which points to the next node in line, and we will call that next. And so that is sort of the instance variables for the node. And then we're also familiar with each class. It has its instance variables, and it also has the constructor, and then it has the methods. So we can actually have a constructor here, and we're going to call this the same name as we had in the class. And what we're going to have inside this node is we're going to every time we create the instantiation of a node, which it makes sense to, and we'll see shortly why. But whenever we create a node, we want to have default values for what the value is and what the next is, right? The next reference. That's sort of the main purpose of a constructor, is it sort of defaults the instance variables, as it were. It makes sense to pass in a value whenever I create a node. And I want to make sure that the constructor knows that the value that I've passed in is referring to the same value that I see on the class level. And furthermore, within the node, I'm also going to default the next, this dot next. I'm going to say it's null. Now, I'm going to say it's null because when you create a node, it doesn't necessarily point to anything. That would have to be taken care of by, this overarching implementation of the linked list. I don't think it would be maybe wise to make this private, just because I may have to use getters or setters. And for simplicity's sake, I think I'll just leave this as it is. But the point being is that I have an embedded node class, and this is essentially the class in its entirety. So this can sort of be blocked out. We'll just sort of ignore this for now, although this is going to play an important part in building the linked list. But let's just glance over this. We've created the basic template of each of the nodes that the linked list contains. And within now let's start actually building the linked list class. So the linked list class characteristically has a node called the head node. And the head node, and there are many, sort of, there's a lot of functionality that you would try to sort of establish, which would use the head node. It sort of gives you a handle on the linked list as, okay, this is the head, right? And so it's kind of like when you grab someone, or you kind of tug on their hand to get them, right? And that's kind of what this head node does, is it allows us to have a handle on this linked list, and then from there we can do a lot of things. So we have a no, and this is the attribute for the linked list class. We have a head, and then we're gonna linked list implementation. We're gonna create that constructor here, and I don't think, I mean, you could probably, but it doesn't, I mean, when you create a linked list, you just create it, right? And so I'm just going to make sure that this dot head points to null when I create it, because, as soon as I create it, there's nothing, right? I mean, the head node is no node. There is no head node. It's just null, because I haven't added anything as soon as I've created it. But on the topic of adding things, let's get to the add method. So we're going to essentially add an element to the node, or to the linked list rather. But before I do that, we're talking about the head being null. What does it mean for the head to be null? It means that we haven't added any elements within the linked list yet. So we can actually create a method called, it's going to be a Boolean method. It's going to be called isEmpty. And this is actually a common method that you find in linked list as well, where it returns true if the list is empty and false if it's not. How can we judge whether it's empty or not? Well, we can return whether the head node is equal to null. This is going to return true if this condition is satisfied, and false if it's not. So if in fact we've added nothing, and the head, then the head by default would be null, and this would return true, and it would say it is in fact empty. However, in every other case, it would return false. So this add method, it actually uses this method as part of its implementation, which is why it's useful to talk about that first. But this public method add is going to return a Boolean. I think what they say is it returns true if you're able to add it, and false otherwise. So this Boolean method will be called add, and you're going to pass in an element. Now, again, it makes sense to pass in data, right? It makes sense to pass in data when you want to add something to your linked list. And what you're going to do now is you're going to create a node. You're going to create a node that receives that data. So this is where I begin to use this node implementation up here. I create a node. Let's call this new node equals, we will say new node equals new node. I think it was, I forgot the name, but someone said in Java you have to say everything 3 times, and that this reminds me of that. When you create an object, you say node, and then you name it something that sounds like the object, and then you name the object again. But nonetheless, we've created a node that has data. And of course, since we've created it, this particular piece of data is tied down to the node, but its next pointer points to null. And so at this point, we essentially can, let's judge if the list is empty. So we will say if it's empty, then we don't want to add, right? So if it's empty, then we will just return false. We couldn't add anything to the list because it was empty. Now, actually, that may not be a proper thing to do. If in fact the list is empty and it's the first item that you're adding, then the head node will point to this new node. So the head is going to point to this new node. So this new node is now the head of the linked list that we've created. And then we'll just return true, right? Because we were able to add an element. So if it's empty, then the head is this new node. And there you have it, right? Now, otherwise, so you could say else and then, have your logic in here. But the thing is that if this is true, then you return something. So it's not the case. There's no reason to make this else, right? Because if you're in here, you return true and this code doesn't get executed anyway. So, we can just start our implementation here. So if it's in fact empty, then your head is the new node and you return true. Otherwise, what you do instead, if there are already items in the list, existent items that you've added prior to this, what you do is you create a current. So you create a node, node current equals, and you point it to the head of the list. Okay, so this is actually what's happening here. Suppose we already had items in this linked list, and of course we know that these linked lists, they have references and it points to the next one in line. And the idea here is that you're gonna create a current pointer. So you're gonna create a current pointer, let's say current, right? And it's pointing right here. You're gonna create we create a node. It's sort of a temporary node. We create a node called current, and which we've done here, and it points to the head. Okay, that works. We've created this node called current and it points to the head. And essentially what you do is you say, while current is not null, okay, while current is not null. So why do we say while current is not null? Because if you come down here, when we say, this current is essentially going to, it's essentially going to move up one at a time, one at a time, one at a time, and then it's going to hit null, because over here you actually have null. And when it hits null, then you've iterated. This is a way to iterate through the entire, entire list. So let's see that again. Current, you start at the head, and then you iterate once, you iterate twice, you iterate 3 times, you iterate 4 times, and then you hit null. So this tells us that we've iterated through the entire linked list, right? So while current is not null, but how do we inspire that movement of moving ahead? We say current equals current.next. So what that does is it essentially, current, which it is now, is referring to this node, right? And current is equal to current.next, which means current, which is this, is going to equal current.next, which is this. So that's how on each iteration we say, okay, current is equal to what current was before, and then .next, right? And then you get the new node in line. And then if you keep doing this until you hit null, you're essentially iterating through the length of the linked list. So current is equal to current.next, and until current is not null. And you're gonna essentially, what you wanna do while you're doing this iteration is, so what we really want to do is we don't necessarily want current to be at the end. There are some cases where it makes sense for current to hit null, but it would make sense for our case to be one before null. So we instead want to have current point to the last node, so that we can take its next property, because this is a node, it has a next property. We can take its next property and set it equal to, we'll say that node dot next will be the new node that we created. And then effectively it would be the last node in line then. So this node that we create, we're going to get a handle of the last node in line. And then we're going to say, okay, that node's next property is the newly created node. So then that node, this new node, gets sort of in line with the flow of things, right? So instead of saying, while current is not null, because then we're gonna end up, at the end, right? Instead of saying that, we're going to say while current dot next is not null. Okay, because what that's going to do is it's going to bring us here, because current dot next, this node here, what's its next pointer pointing to? It's null, right? So while current dot next is not null, keep moving current forward. So it's going to stop right here, and then its dot next will be null, and so it's going to stop at the last node instead of moving its way down to null. And then you can say, then by the end of this while loop, you can just say current dot next equals the new node that you created. So then effectively this last node's next pointer is going to be pointing to the new node. And that's essentially how you do it. You say current dot next is equal to new node, and then effectively you've added, turn true, you have added this new node to the end of this singly linked list. Now, let's try to print this out. So what I want to do here is I want to create a method, because we're gonna experiment with, you know, with this add method here, but we want to actually, once I add them, I want to have a way to show you. I could show you in the debugger, I think, but it's not that intuitive, nor is it any more instructive. But I'll create a, you know, this is going to be the print method. I want to print out all of the elements in the node. This is going to be a print method. So public, it's not going to, I'll say void, public void print. And what's going to happen is I want to iterate through the array and grab each value at once. So again, I want to create a node. It's going to be called current. I'm going to point it to head. I'm going to say while current is not null. Okay, I can say while current is not null because I actually want to visit each and every single node. I don't want to just stop at the end. While current is not null, what I essentially want to do here is I want to say current equals current dot next, and I want to actually print the value out. So I'm going to do you know, system.out.print line current dot value, and then so what's going to happen here is, you know, everything we've already covered this part. You know, we've already covered you know, establishing the current at the head, and then saying that current equals current dot next, that inspires the movement to the next node. And while current is not null, it keeps doing that, right? So this is we've already covered this, right? The only addition here is on each iteration, it prints out the value, current dot value. It prints out the value of that node, and then it moves to the next, and then it moves to the next. And so here in the main method, I can essentially create an instantiation of the linked list implementation. I'll call it my, and then I have to actually specify what type. I'll say, you know, this is of type string, and I'm going to call it, you know, my list equals new linked list. Then I get to access that add property. I'll add a piece of data. Let's say I'll call this, you know, John, and then I'll duplicate this a couple times so I can add more elements. I'll say that this is Sarah, and this is, let's say, Tony. And when I call my list.print, I should be able to get John, Sarah, and Tony out on the screen, which you see here. Let's see, could I maybe do something a little more, you know, you could remove the line here, and then maybe you could add a space. And once you have that space, you can add this. Let's see what that would do. It gives them, it kind of puts them in this format here, where I have my elements and then I have my pointers. If I didn't have that space, that's actually a little better, right? And if I didn't have this one, then they'd sort of be mushed together like that. I think that's a little better, right? So you can see that I've successfully added all of these values here. And that's a basic implementation of, you know, the linked list. Now, this implementation of iterating through the, you know, the linked list, it's very common. Suppose we wanted to create a method called contains, and we wanted to find out if the, let's say I have a method here. I say my list dot contains, and I wanted to pass in, let's say, Tony, or anything of that type. Then you would iterate through. So you would have a method, and then you would call it, it would return true if it contains, false if it doesn't. You would iterate through the length of that array. How are you going to do that? You're going to do that using the while loop that we have, right? So we use while. You're going to create that current node while current is not null. Keep iterating through, but on each iteration, check if the target that was passed in by the user is equal to the node's current value. And so this iteration has a lot of merit, but nonetheless, this gives you a basic understanding of a linked list, and then I'll leave some of the other implementations to your own discretion.